We start with Unit 2, Day 1, and this is a Intro to Functions. This is Part 1, because next class we got Part 2. This is still in our same Cornell format, so I still got my line down here, got my title, but now you have the ability to pause and rewind and use the laptop to take care of this portion. So here goes the first part of the notes. If you need to go ahead and pause it and write it down, go ahead and do so now. Right here, we're talking about functions. And something, an equation, is a function if no x value repeats itself. And this whole x value, we keep saying these different words, but x values is the domain. Don't forget about that. So no x value can repeat, or no domain value can repeat. There is one exception though. An exception is if there is an exact, meaning same, there's an exact point, then it's okay to repeat. An exact point can repeat and still be a function. Okay, so we want to determine what is a function, what's not a function. Yes, that is. No, that's not. Let's take a look at these 2 points. And what we're looking for, if no x value repeats, then yes, it's a function. So let's take a look. Well, points are written as x, comma, y. X, comma, y. I look at my x values, also my domain. I'm going to kind of keep throwing that out there. My x values is 1 and 5. Did these two numbers, all right, so 1 and 5, are these repeating numbers? Well, no, they're different. So no, the x value did not repeat. So yes, this is a function because my x's did not repeat. I'll get a second question or a second example. I have 6 and I have 2. No, those do not repeat. So yes, it's a function. -2 and -2. Uh-oh, my x value repeated. This is the same number. But it's okay if it's the exact or the same point. Nope, this is -2,4, that's -2,9. These are two different points, so it's not the exact point. And my x is repeated, so no, that is not a function because it's the same number. Last one here, -1 and -1. Uh-oh, same number, my x value repeated, but that's okay as long as it fits the exception rule. The exact same point can repeat. Are these exactly the same? Well, yes, they are. So that is okay. This is a function. Once again, if you need to pause the video to write stuff down, go ahead and do so. Now, let's take a look at some examples and different ways we can look at functions. One way is by a table. Well, in a table, I can fill this out. Let's say we had the values of -3, 4, 7, 8, and 10. Let's say we had y values of 15, 10, 15, 11, and -4. Well, I'm going to determine, is this a function, yes or no? We're looking for the same thing, as long as no x value repeats unless it fits the exception. So, once again, my x values can also be called domain. These are the same thing. X values is your domain. So I'm just going to list these out. I have -3, I got 4, I have 7, I have 8, I have 10. My range is my y values. That's another word we can use. 15, 10, 15, 11, -4. Now, it's a function if no x, no domain repeats itself. Well, these are all different. Now, I do see 15 repeating, but these are what? That's right. These are y values, and we don't care so much about the y's because we're looking for the x values. But since all of these are different, then yes, this is a function. Okay. We also have another one called mapping. And mapping can be where they have values on the left side. I'm going to put 1, 4, 7. They got values on the right side, -2, 0, 6. It could be anything there is. And it maps from one side to the next. We say that 1 maps to 2. 4 maps to 0. 7 maps to 6. And 7 maps to -2. And just like a table, the first row or the first column is always the x. The second row or the second column is always the y. No different in mapping. This first column is going to represent the x or the domain. The second one's going to be the y. And every line is a point where it starts off as the x where it starts, comma, where it ends is the y, and that's how I get my point from left to right. So if I looked at this first line, my point is 1, comma, negative 2. 1, comma, negative 2. That's a point. Every line is a point. Here's another line, 4, comma, 0. 4, comma, 0. I have 7, comma, negative 2. But there are 2 lines off 7, so I also have 7, comma, 6. Okay. 4 lines, 4 points. I'm looking, is it a function? Do my x's repeat? 1, I'm looking at 1, 4, 7, 7. Uh-oh. The 7's repeated. Are they the same point, though? Negative 2 and 6? No, these are not the same point. My x is repeated, so no, this cannot be a function. Okay, and another big hint is, since I have 2 lines that start on the x, so these are x's, so I got 2 lines that start here and they go 2 different directions, that's also an easy tell to say, nope, not a function. Okay. We can also go by graphs. And if I have graphs, what we use is what we call the vertical line test. Vertical line test. Or I'm going to abbreviate that to VLT. VLT, the vertical line test. And that's probably the easiest way to look at a graph, where if I had a vertical line, for example, my pen, vertical line, the graph can only touch my pen one time on a vertical line. If it touches it more than once, then nope, my x repeated, and it's not a function. So if I take a look at this first one, and I take my pen, well, it only touches it one time right down the middle. One time, one time, one time, one time, one time, one time. It only touches my vertical line one time, all the way from left to right. So yes, this would be a function. If I kind of shown you with the pen where I just make vertical lines, no matter what vertical line I make here, no matter what vertical line, the graph, here's my graph, only touches the vertical line one time. Once, 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 once. That's the vertical line test. Look at the second one though. Look, if I make a vertical line right here, doesn't matter where, once and twice. Make a vertical line here, once and twice. So no, this is not a function, because it did not pass the vertical line test. Once again, it can only touch the vertical line one time, not twice. Look at the third graph. Well, just to make a note, this is kind of introing, planting the seed for down the road here. We also have an open dot, closed dot. This open dot means not included. This closed dot means it's included. Okay, that's going to kind of help us out here in a little bit. But if I do a vertical line test and I run this vertical line one time, one time, one time, one time, one time, one time, nothing repeats. So yes, this is a function. Yes. Take a look at the last graph. Vertical line, that's a vertical line right there. So, vertical line test, nothing, 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 so far so good. But when my vertical line touches it, every point is on my vertical line. Not just 1 point, not just 2 points, not 3 points. Every line touches my vertical line. And since there's more than 1 point, no, that cannot be a function. The last way we can represent this is by using an equation. And let's say we had the equation 2x minus 3. Y equals 2x minus 3. The best way on this problem is to use the calculator. Okay? And we're going to plug this into y equals. And when we do, we're going to take a look at the graph. And we're going to determine vertical line test. Does it pass it, does it not? You could also look at the table and check out the x values to see if they repeat. So, if I get my handy dandy calculator here, Okay, and I'm going to go ahead and click on y equals. And from this y equals, I'm going to type in 2x minus 3. There it is. I'm going to hit graph. And it looks like a linear line. Vertical line test, 1 point, 1 point, 1 point, 1 point, 1 point. Looks good to me. I passed the vertical line test. So yes, that is a function. So look at a couple more examples now. Something that you're going to see more like on your exit ticket today. So please, please pay attention here, ladies and gentlemen. Example, which of the following is a function? Which of the following is a function? What that means there could be more than one. Let's see. 1. Here's my x, here's my y's. Do the x's repeat? 1, 3, 5. Nope. These do not repeat, so yes, this one's a function. There it is, yes. The second one here, vertical line test. Nothing, 1, 1, 1. Uh-oh. Look right here. What we said was this is not included, but this is. That means this one also is. And if I drew a vertical line between these two, more than 1 point touches my vertical line. So no, that is not a function. Everywhere else, 1 point, 1 point, 1 point, 1 point, 1 point, 1 point, looks good. But because there's a solid dot on top of a solid dot, that is not a function. More than 1 point touching the vertical line. Okay, so 3. Negative 1, 5. 0, 8. Oh, here's a double. A double on my x. Now, this is y. So my x, here's a repeat. So no, that one doesn't work. Number 4, I need to go ahead and graph this. So let's go to my calculator here. Y equals, I say 4x minus 1. Graph. Vertical line test. Yes, 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 yes. Okay. So 4 is a yes. Okay, and 5. 0, I'm going to get my x as my domain. 0, 5, 4, and 0. Uh-oh. These two repeated themselves. Oh, but look. This is the what? Exception to the rule. Those are the exact same points. So yes, that is okay also. So we have 1, 4, and 5 are functions. 1, 4, and 5. C would be my solution. Okay. 2 more and we'll be done here. Example. Which of the following would not? Key in. Are they going to say would or would not? In this case, it's would not be a function given. So what that means is, if I plug in one of these numbers into W, the unknown value, because that's what we're trying to determine, question mark, what that is, then which one of these would not make this a function? Well, let's see. If I take 9, and I'll plug 9 in here. 4, negative 2, 7, 9, 11, 0. Did any of those x's repeat? Nope. So this is a yes. That would be a function. If I plug in 4. 4, negative 2, 7, 4, 11, 0. Notice we said 4 and 4. Well, 4, 12 and 4, 12. Oh, that's the exact same point. So that's okay, because it's exactly the same point. 0. 4, negative 2, 7, 0, 11, 0. Uh-oh, 0 repeated again. 0 and 0. 0, 12, 0, 2. That's different. No, but let's keep going. Let's double check. 4, negative 2, 7, 6, 11, 0. Oh, those are all different. So yeah, that's a function. C would not make it be a function. And last one. Find domain and range. Determine if the given is a function. So here we have it. Domain, ladies and gentlemen, represents what variable again? That's my x, and range is my y. Okay? And my points are listed as x, y, x, y, x, y, x, y. So if I want to list my domain, it's all my x's. 1, 4, 7, and 12. My range is 6, 19, 6, and -1. And it's a function if my x's do not repeat. Doesn't matter about y's. Remember, range is y. We don't care about this. Look at the x's. 1, 4, 7, 12. Nothing repeats. So yes, that is a function. Okay, don't forget to go back and fill in the sides about what's important, or if you have questions, and finish your Cornell notes up.